All right, let's say here is our expression, and we need to simplify this because there is a radical in the denominator which we know cannot exist. Okay, so our first step is to simplify all radicals, okay, just like it was in the other one. In the other one, the reason, again, is we want to work with the smallest bases possible. So in here, are there any perfect square factors you can remove from what's in the square root? No. Okay. Now, all the double term denominator problems that you're going to have will only be involving square roots, so you won't have to worry about anything more complicated than that. Okay, so there's no perfect square factors that you can remove from step 5 or from root 5, so we can move to the second step. And in this, the second step isn't to build up to the nth root of a to the n like it was in single term. In this one, what we're going to do is rationalize by multiplying the entire fraction by the conjugate over itself. Okay, so let's talk about what a conjugate is. Okay, the conjugate is the following. Okay, if I have an expression where I have the sum of two terms, and I'm going to write it in terms of a radical, the conjugate is the exact same terms, so a and b root m. The only difference between an expression and its conjugate is the sign separating the terms. So here the sign was a positive, so here in the conjugate the sign will be a negative. Okay, so that is how you find the conjugate. You just take the original double term expression, rewrite the terms, change the sign between them. Okay, so here for that particular step, if I were to identify the conjugate, we're using the same terms, 7 and root 5, opposite sign between them. And now, it's not changing the sign of both terms, which would be a common mistake. It's simply putting the different sign in between. So it was a sum, so this one's going to be the difference. Okay, now, this works in the other direction as well. So if my denominator had been the difference of two terms, the conjugate would be the sum of those same terms. Okay, the whole reasoning behind this, or using a conjugate, is based on the following relationship. Okay, if you guys recall from algebra, one of the special product forms is if you multiply the sum of terms times the difference of the same terms. If we were to FOIL this, so our first gives us a squared, our outers give us minus ab, our inners give us plus ab, and our last gives us minus b squared. What's going to happen here is the outer and inner products, so again the inner products and the last products, the outer and inners are going to cancel. They're exact opposites of each other. Therefore, you leave the difference of two squares. So the sum and difference, the special product form of the sum and difference of terms is equal to the difference of those terms squared. And that's the basis for this, because if we have a radical in one of our terms, if we can multiply this by something so that our answer is the difference of these two squares, so the difference of 7 squared minus root 5 squared, that eliminates the radical completely from our denominator. And so that's why the conjugate's used there. Okay, so once you multiply that through, you can then look to simplify your fraction completely. So take whatever the resulting fraction is, simplify it, cancel common factors, rewrite it if you need to. And so if I complete this step right here, multiplying through, and now notice in my numerator, my suggestion is leave it as factors. And later when you guys start to graph rational expressions, it's more useful anyway to be in the factored form. So one, it'll help you in that way, but two, and for you guys here, it just eliminates one extra step where you might make a mistake or a careless mistake. So just leave it as factors. And then across the bottom, I'm going to write this out. It becomes the difference of these squares. So if we take the term 7, square it, minus root 5 squared. Now, you could do this step mentally if you want and just write the answer. I'm writing the steps just to explain where the things came from. Okay, and so if I take 7 squared and then root 5 squared is just a 5, I get my final answer in this form. 49 minus 5. Now, when I look at this last step here of simplifying, are there any common factors I can remove? This factor of 2 out front reduces with 44, leaving your answer 7 minus root 5 over 22. So that would be your final answer here. And the other thing is, coming back to this, if you had distributed your 2 through, you wouldn't see that it can cancel factors with the denominator. Okay, so again, I suggest that you leave it as factors. Do not worry about distributing it through. Okay, let's take a look at another example. All right, when you rationalize a denominator with a radical, it may have just one radical in it, but it can also have 2. It doesn't change the steps in the process that you would use. So if we were simplifying this radical, simplify each individual radical, root 2 and root 3 are already reduced. Multiply by the conjugate over itself, so we take the same terms, root 2 and root 3, and we simply change the sign. So we were taking the difference in the original denominator, so we change that to a plus or a sum. And so now across the top we get a 3 times the quantity root 2 plus root 3. And in the denominator we take our first term and square it, so root 2 squared is 2, always a minus, and then our second term squared, root 3 squared is a 3. And so if we simplify this, we get 3 times root 2 plus root 3, all over negative 1. And don't leave a negative as a factor, especially in the denominator. Just, you can move it. So we'll move it up to the numerator. It becomes a negative 3 times root 2 plus root 3. So this is the form of your final answer. All right. The last example that I want to go through is the one that would tend to cause the most problems in this section, and that is modeled by the sample problem 14E. And so just take a moment, see if you can answer this question for me, please. Try to reduce and simplify this fraction. If we're working through this, we simplify our radicals. There's nothing to be reduced. So we can multiply by the conjugate. The conjugate is same 2 terms, 3 root 5 and 2. Opposite sign between. It had a plus, so the conjugate will have a minus. And now when we multiply across, just leave it as factors. There's no need to distribute. And then across the bottom, again, I'm going to write it out just to point out the common mistakes. So we take our first term squared minus our second term squared. And now, here are the most common mistakes. For people who try to distribute through the top, oftentimes what happens is, what did I do wrong in this if I tried to simplify my numerator as 6 root 5 minus 2? Better. Right, so I'll get to the bottom one in just a second, but you are right, that is the most common mistake. But in the top here, if I were rewriting my numerator as 6 root 5 minus 2, what mistake did I make? Messing. Yeah. And it's a very, very common mistake. So I forgot to distribute the 2 all the way through, so this should actually be a negative 4 here, if you're going to do that. Again, I just leave it as factors. You don't need to reduce it down. And then in the denominator, exactly the problem that most people have is they forget to square the 3. This is a power of a product. So this power applies to all factors of the product. So it applies to the 3 and the root 5. So what is 3 squared? 9 times what is root 5 squared? 5. So 5 times 9 is 45, and then minus the 2 squared. So really what you're looking at, 6 root 5 minus 4 all over 41. So this is the simplified form or the expanded form of this. You could have also, though, left it in the factor form up above. That would work too. And in fact, that would be my preference. And now, if you're entering these online, the way that these would be entered online, the first one, 6 square root 5 minus 4. And now, if you have to enter it all in one line, the way that you would do this is, because if you just put slash 41 here, order of operations wise, the 41 is only being divided into the negative 4. So what you would need to do is include parentheses around it. So this would be your entry in a single line. If I gave you an entry where I provided one line with a fraction bar and then another, you would wind up with your 6 square root 5 minus 4. You wouldn't need any grouping symbols. And then in the denominator, you could put your 41. So those would be the two possible forms of entering your answer. Okay. For the second one, if you left it in this form, the way that you would enter it would be 2 times the quantity 3 sqrt 5 minus 2 parentheses slash 41. This one is fine. It already has order of operations taken into consideration with the grouping symbol. Okay. And if you were looking at the two different entries, so a numerator divided by the denominator, in this particular case, the way it would look is, again, you'd still need all your grouping symbols here, and then the denominator would simply be the 41. So either of those forms would work as well.